So in our fourth chemical bonding video, we are going to look at covalent bonding, and particularly molecular covalent bonding. So this is what happens between nonmetals and nonmetals, and we're just going to initially deal here with the small molecules. In the next video, we'll cover continuous covalent bonding lattices. So a covalent bond is essentially a shared pair of electrons, and two nonmetals will share their valence electrons so that they both think they have that electron, and that helps them think they both have a full outer shell, which is what all these atoms are trying to get to. We'll do a couple of examples and hopefully that will become more obvious. So what we're going to do is use electron dot diagrams and structural formula to show covalent bonds between non-metallic atoms. And hopefully what that all looks like will become clear as we go. So let's start with an example using oxygen. So oxygen has an electronic configuration of 2, 6. We're only going to worry about the valence electrons. So we draw our oxygen atoms and we have 1, 2, 3, 4, 5, 6 electrons, and we usually draw those out in pairs. They pair up with opposite spins. If you remember back, most of those subshells, when we did the subshell notation, all have sort of 2 electrons in each subshell. And then we get our other oxygen atom that comes along, and just to make it clear, so these are both oxygens, but just so it stands out, we go 1, 2, 3, 4, 5, 6. So that one has its 6 electrons. And now when we look at it, this atom on this side thinks it has 8 electrons, so it's happy. This atom on this side thinks it has 8 electrons, so it's happy. And we have 2 shared pairs of electrons, which is effectively means we have what's called a double bond. So a covalent bond is a shared pair of electrons. A double bond is where we have 2 shared pairs of electrons. So that is our electron dot diagram there. Then that is our structural formula showing how those 2 atoms are bonded, and basically each line represents a shared pair of electrons. Let's look now at a very common chemical that you're probably familiar with, which is water, H2O. Now we know that hydrogen has just 1 electron, and oxygen, as I said before, is 2, 6, so there's 6 valence electrons. Hydrogen wants to get to 2 electrons. Oxygen wants to get to 8 electrons. So how does that happen? Now we normally start with the central atom, and we go 1, 2, 3, 4, 5, 6. And we can see we've got these 2 unpaired electrons, or the 6 with these, if you like, 2 holes where we need 2 more electrons. And then the hydrogens come along with their 1 electron, and this hydrogen comes along with 1 electron. And now this hydrogen thinks it has 2, so it's happy. That's a full outer shell for the first shell. This one thinks it has 2, so it's happy. The oxygen thinks it has 8, so that's happy. And to draw that structural formula, we draw oxygen, and then we have 1 shared pair of electrons here to hydrogen, 1 shared pair here to the other hydrogen. And sometimes we can either use dots or crosses. We will even put in those 2. So that's showing what we call our unbonded electrons here. These ones aren't shared, so they're unbonded. You can leave those in. You can put those in if you want. You can leave those out if you want. It's not critical. So let's just do one more example there. let's say we have nitrogen, which is 2, 5, and we have hydrogen, which is 1. Now I'm not putting the formula here because I'm showing you can actually use this to work out the formula. So if we've got a nitrogen in the middle, it's going to have 5 electrons surrounding it. So it wants to get to 8, so it wants 3 more. If hydrogen comes along, hopefully you go, well, each hydrogen can only give it 1, so that we're probably going to need 3 hydrogens. Now each hydrogen thinks it's got 2, so they're all happy. This nitrogen in the middle now thinks it's got 8, so it's happy. And we can write that structural formula N. Now we'll talk more about the structure. I've already talked to some of you guys about the structure of these, but we will come back and talk more about the structure of these later. But for now, we don't need to focus too much on that. So hopefully that gives you an insight into how we work out the formula for molecular compounds consisting of non-metals, how we do an electron dot diagram to work out the bonding, and then how we turn that into a structural formula like so. So just quickly talking about the properties and how this relates. Mostly molecular compounds have low melting and boiling points. They're in fact usually gases or liquids at room temperature. There's enough energy even at room temperature to cause the molecules to form a liquid or a gas. That is because the bonding between the molecules, which is what we call secondary bonding, or secondary bonds, is much weaker than the primary bonds. So the primary bonds are these bonds within the molecules. These are quite strong and these are quite hard to break. But, say in water, we get very weak secondary bonds between this water molecule and all the other water molecules in water. And we're going to talk a lot more about this in detail later, so you don't probably need to know the detail of this now, but be aware that these things do tend to have low melting and boiling points because of the weak bonds between molecules, and as we go on, hopefully you understand that. They also don't conduct electricity because they contain no free charged particles. There's no free ions, there's no free electrons, so these in general can't conduct electricity. So that's covalent bonding.